There we go. Alright, hi there. I'm not sure if anyone can see me, but if you can indeed see me, then you are welcome to say so in the chat. And if you can hear me, if you can't hear me, please indicate as well. So this has been quite a lead up to this GRiSP stream. You might not know me, I'm Tiens Botha. I work with the GRiSP team, and yeah, I'm busy trying to set up a rover that we bought from Server City, and we are now attempting to get all the motors working and all of that. Yeah, so I'll be attempting to run a motor, and if we manage to get that right, let's see if we can read the sonar that we will be installing on the GRiSP device later, on the robot that we bought, and that we will be showcasing or doing a workshop on at the CodeBeam conference next week in Berlin. So this is my first time doing this, so I will be trying to figure out how to do it and how to do all the multitasking, and hopefully you find it interesting. Alright, so what I have done so far in preparation was to get the board up and running, get a sample app, do all of the little things that one does to get started, and now I currently have a terminal open onto a live board. What I normally do when I start anything is I blink the light just to be sure that that everything is in order. So let us quickly find a bit of example code that I intend to paste there. Perhaps I switch the screen to the where I'm browsing. Alright, I connected over Wi-Fi. I'm on a serial port because the Wi-Fi connection doesn't seem to work, but the serial port, you know, it also does do its thing, so we should be fine. We shall be doing the following. GRiSP LED. Let's see. Let's go to the example, the docs, and see what the LED can all do for us. So if we give it a color and a number, then we should get it to flash. Well, to switch on. Okay. I did potentially fry the board earlier today, so let us hope that is not the case, and that we can actually get this to work. I think we should have. Alright. Documents, let me quickly open a few things here, just so we do not struggle. Alright. So, there's my atom that I currently have open. This is my text editor that I use normally. It is quite useful, and since we don't have a live terminal open, a Wi-Fi terminal, but rather a serial terminal, and you can't get live feedback of what you're coding, I am going to try to just paste the code here, so that I can see what I'm doing, and then paste it in the terminal. Alright, so far so good. If you look in the bottom corner of your screen, you shall see the LED is on, red light, cool. Let us see now. Let me show you quickly how I set this all up. We have so we bought this little battery holder from Servo City, which works quite nice. I soldered a few wires onto it just to, get it easier to connect to whatever else we're doing. I've got an HB5 motor controller and and then I've got some motors from Digiland, which we will be trying to run. And the HB5, how that works is as follows. So the HB5 has these 6 pins. The ones marked dir is direction, the one marked EN is enabled. That is the one you pull high so that you can get the motor to work. One can also apply a pulse width modulation signal on there, so you can vary the speed of the motor, as you can see here. And one big rule of these H-bridge motor controllers, which is bi-directional, is that you should never have the enabled pin high when you should switch direction. So that is something that I shall be trying to remember today, and hopefully we don't break anything that is not already broken. So I've got the VCC connected, I've got the ground connected, I've got the dir connected, the direction. So the direction will be low goes one direction, and if you pull it high, then it turns in another direction. So we can probably try both directions today. The most important bit to remember is just not to have the motor running when you manipulate the pin, the direction pin. Okay, we are leaving this SA and SB today. That is a feedback mechanism from the motor so that you can figure out how fast the motor is going. In case you want to control the speed, we will just be attempting to have it go at full speed eventually, if all goes well. Because we have not so many PMOD ports available, we would like to run 2 PMODs off of one port, and that we will be using in that case we will use this SA and SB pin to drive the direction and enable pin on another PMOD, another HP PMOD, both from the same PMOD port on the GRiSP device. That is something that we hope will work, since I had it plugged in earlier and I saw smoke coming out of something. So let us hope this works in the long run, but if not, we will learn from it. Okay, so we will obviously already have a direction that we can go in by just not doing anything with the direction pin. So the first thing to figure out is how we get the enable pin high. And that, in order to do that, I will be going to the docs once again so that we can see what the docs tell us. Let me show you the docs that I am going to. Yep. This is my browser window. So we saw here that we can put the LED on and off, but what we would like to do now is put a GPIO pin. That's the general input and outputs. One generally needs to configure a pin to be either an input or an output. before you do a get or set on those pins, I believe, but to be sure we can go to the actual GRiSP source code, I suspect, and there we should be able to see how it gets done in the GRiSP modules. I think we shall go into the GRiSP base. That is not correct, I think. Alright, every now and then I'm gonna just look in the browser to see. Alright, Pierre said something. Alright, let me check. Pierre, if you want to chat, and tell me if you now see the screen. Then that would be great, because that will indicate whether or not other people can see the screen, which obviously is something we want since we're in a live stream. I only have a single screen today. Okay, Pierre gave me some advice here. So the thing is that with the H-bridge circuits is that when you change the direction while you can have an intermediate state where the VCC is connected to the ground, and then you should circuit the H-bridge device, and that is then when smoke comes out. So we actually spoke about this earlier, and we suspect when the device started up it might have by accident, due to not strictly controlling the pin states, it may have gone into one of these short circuit modes, and that is something we will have to figure out as we go along. Or maybe not today, since there's not enough time, but in time we shall figure that out. Okay. Let us locate where the Erlang code is at for these things. So, I think some of you may have seen the source code of GRiSP already. It is broken up into different drivers that is driven in different ways. Let's see the GPIO module. That is where slots get configured. So we would need to give it a mode, I suspect. So if you want to configure something, you give it a pin and a type. So we will be looking, I suspect, at pin 1, that is GPIO 1, pin 1. I'm going to first do individual pins. We will be looking at pin 2 actually, because we want the enable pin to go high, not the direction pin necessarily. So let us configure pin 2 then to a output type, like they do here, except you want, sorry, multitasking is a bit difficult, so we will configure GPIO1 pin 1 the same as here, and we will give it a type of output. So the output types we have different output types. There is an output that is default high, and then you set it low, and then you also get a default low, and then you set it high if you actually manipulate it. So let us see. We would want to put it as a output 1, I suspect. We may want to put that in the docs later on, which output means actually which type of output, as in what word do you use to say what you want to say. Alright, there is what I'm going to paste in the terminal now. We're just putting GPIO1 pin 2 to output 1. I'm just going to quickly check if there's any comments. PS said that he can't see properly, but it is probably his bandwidth. Okay, that is unfortunate. Okay, let's see what happens. This is a bit of an experiment for me too. Yeah, we obviously need to tell it which module to use and not just what function to call. These are private functions, so that is not going to work. Oh no, it is exported. Okay, so you're going to try GRiSP GPIO configure and put it to output. The syntax I'm not so used to, so forgive me if it takes a bit long. Alright, I saw little lights flash here on the GRiSP board, which I think is a good indication that something is happening. Let me show you the terminal so we can have a live view of what's going on. Okay, I suspect we may be almost there, or we are going to see sparks fly and flames, which is not going to be pretty. Alright, now that we've got it set to output, now we need to figure out obviously how we will go about putting the pin high. So there's a function called set. Let me enlighten you here. So this function set1, that just receives a pin number, and whichever pin number you give it, that obviously will get set, which means that in this case it will go high, whereas in another type of output it would have gone low. Get here would map to an input rather than an output, so you would use that if you had something connected like a level switch or something like that. Then you would read when the level is high enough by doing a get command. The clear command a bit higher up, that is what we will use to switch it off, and I think I should keep that nearby, because motors, when they run and they are not installed in a device, they can sometimes get quite violent. So let's just keep this clear command close by, just in case we need it on a very short notice. Alright, so that is the clear command and that is the set command. I keep forgetting to actually show you what I'm doing. There, so we have a set command set up for GPIO1 pin 2. As we said before, that's the one we configured to be output. And let us see what happens now. Hopefully I did not fry the board, and hopefully we actually do get some fun out of this. Right. No, it seems not. I'll quickly check the wiring. Everything seems fine. No smoke. Probably finished smoking by now. Alright. Then maybe we should go find out this output 1, that this really means what we think it means. Okay. Let me switch that off again in case we are busy being pyromaniacs and causing a fire here in the communal workspace that I'm in. Okay. Cool. So far so good. Actually not. Let me see if I can find another PMOD in the meantime. I have, sorry, that's a bit barbaric, but I have actually got PMODs here that might be fried. So I'll see if I can install a new PMOD. And maybe that can work better. So I suspect you can see the terminal. No, you can't. Alright, there. So why you are not seeing anything interesting there is because I did plug out the USB cable before I started fidgeting with the motors and stuff, because it in general is not a particularly good idea to work on any electrical or electronic devices when they're plugged in. But I suspect most of you should know that already. And now actually I'm going to try to use another one first, one of the devices that may or may not be blown, because I actually don't have a screwdriver to unhook the power cables, which is slightly awkward. Alright, and what I'm also going to do is I am going to use a port that I have not used today to attempt anything on, and then perhaps if we're lucky and the other port is fried, then this one is not fried. Cool. Alright. In the meantime, anyone who knows GRiSP and has worked with it before, has run a motor, and wants to give me some advice, you are welcome to paste something, a message in the message stream, in the stream chat, and yeah, I'll try to take your advice. Okay, now forgot my password for a second. Wait, that can't be caps lock. Okay, I'm going to restart this device. The terminal's going to die again. Okay, and then let's get it to start up. Alright, while that is starting up, everything seems to be roughly in order. While that is starting up, I'm going to go to the docs and see if I can just make a little bit sure about, sorry, let me find this docs again for you. Okay, let me just make sure that I am interpreting the GRiSP IO types as I should. So these are now the C drivers. They are available on the device to be called from Erlang. And then we have higher level Erlang drivers that run on top of them, and they call the C code on the board, and then the board actually sets the different registers in the memory which makes the magic happen. So in the C code we've got a whole bunch of lower level settings and what they mean. Alright, I do not think I see anything useful here, so let us assume we were right for now, and let us see once again if we can get something to work here. Quickly inspecting the terminal. Something seems up. It does sometimes take a while there, so let's give it a bit more time. And then actually I'm going to flash that device again. Sometimes for some reason it does not enjoy being restarted. Something we still need to figure out what the cause of that is. So when you restart the device, it doesn't boot up into the Erlang shell. It starts hanging somewhere because it thinks the Wi-Fi settings aren't correct or something of the sort. And that we will try to fix. Alright, I have put our demo app back on the device, well, reprogrammed it. Let's open the terminal, and once again see what's happening here. Starting Erlang, Wi-Fi starting up. Seems okay. Alright. Now I will let you watch the terminal for a second while I get my commands ready. It's the same commands as earlier. Setting the pin, configuration, and setting and clearing the pin and setting the pin. Now for another port. Actually, it seems nothing may be broken. I had the port number incorrectly. Well, I didn't have the port number right that I was setting. And once the device is started up, I think we can see that maybe I can run the board. GPIO1, it turns out, is this is the second port on the board and not the first port on the board. Right. Quickly checking if anyone's chatting to me. No. Alright. In case no one of you has ever done this before, there's actually quite a lot of multitasking that one has to do. Okay, then I have the terminal out and open. There we go. Perhaps I can show you. I probably shouldn't be so surprised at my own work, but this motor is spinning, and we're lucky that it wasn't too violent and it's not hopping around and going crazy on the table here. But oh well, now it's trying to go crazy. Hold on. This is what we got the clear command ready for. Alright, and it's trying to eat the table. There we go. Okay, great success. So we are now, what we have managed is to configure the correct pin this time, and let me see what you can see there. Okay, so we have managed to set the correct pin, we had managed to configure it to output, and we had managed to clear it when it then did go high and start running the motor. What it tells me that immediately to switch itself on is that we did in fact have the meaning, well, you, me, us. I had the meaning of that output. I had misinterpreted it, and that must be a default on. So what other modes do we have available? Let us see. I can show you, then we can look in the docs. Alright, let's go back to this one, and then we can see what we have available here. So the output types, there's output 1. Aha, here's what I was looking for actually. So output 1 type for the pin, that means it defaults to 1, which in GPIO land, which is a binary system, means on, and that the motor will turn. So I will reconfigure this pin now to a type 0, which is default off, and then perhaps we can control the board a bit more. Right. There we go. I'm going to set to an output type 0, and it is not running, which at the moment for us is good. Let us run it again. Okay, there we go. I got a fright. And switch it off again. Okay, cool. I think we are basically ready to actually start writing some code and deploy to the board, and not just paste things in the terminal. Manipulating the direction, for instance. Let me actually just repeat this step quickly so I can make sure I see the direction of the motor. So those who can't see, I will say it is going clockwise. Alright. Clockwise is what we don't want it to do once we have gotten to manipulating the direction pin. Oh, this goes quickly, eh? We are at 40 minutes already. See if anyone's trying to chat to me in the meantime. No, alright. Back to business. We want to be coding now. Right. A set of commands we need to shove into a function somewhere. I'm not going to hook the function up to anything for the time being. What I would like to do is I just like to have it available. The benefit of the function is going to be that we definitely know that we do not have the enable pin set high when we're trying to change the direction, because we can determine the order of events, which I guess we can do in the terminal too. Maybe I should quickly just do that, make sure that we can get it to turn in the other direction. So my plan in the long run is to set, to have a sequence of events that has a function you can call that you say turn clockwise, turn counterclockwise, and then it will kill the enable pin regardless of what its state is. Never just assume it is off, you make sure it's off, and then as a bit of a time delay, these devices obviously operate a lot faster. The digital devices operate a lot faster than the transient mechanics and physics of the magnetic fields and such, and the bigger switches that's used to drive motors are quite slow compared to the several gigahertz or megahertz devices on the actual processor. So what that means is if you don't have a long enough delay, you can actually do things in the correct order, but you don't wait long enough for the transients, and you can actually still fry the board even though you did do things in the correct order. So be that as that may, okay, you can see atom. So what I'm going to do is I want to have another few functions that I can call. Basically it's the same as the previous one, except we will be manipulating pin 1 this time, which is the direction pin, and we will have a set and a clear for that pin, the same as what we had now. Here we don't have to actually clear anything if we don't want to, it just changes the direction of the board if all goes according to plan. And let us try that. Terminal, cool. There you go. Direction set. Ah, wait. Configure the output. No, yeah. We actually had a default state just now, so we don't actually know what the state was. Cool. Now we have it set to something that we know it is, and we can make, let's clear it. Make sure it's 0. Right. Set the enable pin. Clockwise. Alright, so it did default to what we thought it default to do. Except now we have certainty. Let's clear the pin. Alright. So for the those who are on this chat, I think there's some people who are not perhaps engineers, and I hope you are not too bored, because this is sort of what nerds do, is you play around and fiddle with things until it works, and then you pretend to be clever afterwards. Alright, let's set the pin to what we want it to be, which is 1, and now it should turn in another direction. That was, let me make sure, GPIO1 pin 2, no, GPIO1 pin 1, which is fine, it should be high now, which means if we set the GPIO pin 2, it should turn in a different direction, which it does not. It's still going clockwise. Okay, let's go off again. Come on. Okay. Let me think about this a second. We set. Aha. Alright. Sorry guys, brain fart. I just reconfigured GPIO pin 2 just now. It's actually still not set to anything. Cool. Pin 1. Yeah, pin 1 is now an output. We have finally made it. Let us set it high. Okay. What do you guys see now? Let's make sure. Yeah, terminal. Alright, that's good. And we will be running the motor forward again. No, backward. Aha, direction change. Cool, we are going backwards in the time world, but forwards in the engineering world. Alright, let's clear that pin. Cool. Just reset. Let's also clear the GPIO1 pin 1, which basically resets the direction. Oh, come on. Which sets the direction of the motor back to what it was earlier, and yeah, Bob's your uncle. Okay, this is probably further than I thought I would get, so let us think about what we do next. Okay, we now create a function to automate all of this for us. So obviously the engineering process is to do something until you get it right. Try different things, and don't automate from the start. Once you have managed to get something to work, then you automate it. Okay, so now we are in Erlang world, which is not totally new to me, but it is somewhat new to me. So we would need to create the functions, I believe, and we would need to export the functions. So I'm just going to create it here in the supervisor, which let's hope here, if he does see this, is not too bleak with that situation, because I didn't put too much thought into how one would structure one of these how one would structure one of these software packages or applications, and that is something we'll get to in Berlin next week, is how do we actually write this code to be useful and easily deployed and all of that. So exporting a, let's call it a clockwise let's give it, what should we call it, motor 1, and we will say rotate motor 1 clockwise. Right, so this obviously is not going to do anything useful for us, the code that you can see there now. And let me wait, let us also create a configuration function. M1 configure, M1 configure. So what we will do in M1 configure is, if no one guessed it by now, is to configure. Right, there you go. Copy paste engineering, the best kind. Right, so we are going to set both pins. It's been a long week, guys. I am glad to be coding here, but I will also be glad to sleep later. Cool. Let us have this configure function, M1 configure. Just checking if someone sent a message. No, not no one. Okay. So M1 configure. We're calling two functions. Those two functions are to set GRiSP GPIO pin 1 to output 1, output 0, and GPIO pin 2, set that to output 0. Alright, that would configure the pins. Then to rotate clockwise, we will make sure the direction pin is high, no, low, yeah, low. Oh, man, guys, can you remember? Alright. I'll just rename the functions later if it's wrong. Alright. So we want to set pin 1 to high here somewhere, and then after that we will set pin to high. Good, okay. What we have forgotten to do is exactly what we're trying to avoid, is to set pin 2. We always make sure that it is 0 before we do anything. The purpose of this function, and okay, I'm just checking that I know what you're seeing, and if anyone can't read what I am typing, then I need to zoom in on something. Please let me know if that is the case. Okay, let's actually just zoom in, why not? Cool, that's a bit bigger. For those who struggle to see these things. Okay, so we are clearing pin 2, then we're setting pin 1, and then we're setting pin 2. And in between there, we want to have a delay function, which I think we have an example potentially. Otherwise, we're gonna quickly go to the Erlang docs. But first, let us try to go here and see. They call a function here timer sleep. Yes, you see what I'm seeing? Yeah, okay. So this timer sleep function is one that obviously Erlang can run many processes, and when you want a very specific process to sleep, yeah, you call timer sleep, which is not the most adventurous name, but it is the most practical name. Alright, so once we clear the pin, let us sleep. Okay, and I'm gonna make actually a reset function, m1 reset, which basically just clears everything. So, to those who do not know this, I am not that fluent in Erlang, so I hope what I am writing here is correct. It is. Let's quickly check here. Alright, yeah, I think it should work. I've got to share my screen again. There. Alright. So what m1 reset is going to do is it is basically going to clear everything. And that means that the motor direction will be reset, and that the motor enable will be reset, which means that it will stop. And it will start up, more importantly, in a direction known to us. Not that we're going to rely on that sort of guesswork, but we will. It's always good to try and optimize the behavior to be what you think be what you think it's gonna be. Anyway, yeah, try and make everything as predictable as possible, then you will have hopefully as few surprises as possible. See, later what we could do is we could change these functions to accept inputs, and then we can pick the motor, which will probably be one of 4 when the rover is running. Okay, start exporting functions. M1 configure, M1 clockwise needs to be exported. M1 reset needs to be exported. Well, we shouldn't do so many functions at a time because I do not know if any of it's going to work. Let's be adventurous, because then if we are back in the terminal after waiting for startup and it does work, then we can have some good old engineering fun. Okay, so one of these I wanted to call anti-clockwise. So I have M1 anti-clockwise, M1 configure, M1 clockwise, and M1 reset. Let's make sure all of it's indented correctly. Not that I'm sure it matters that much right now. But if, yeah, alright. Actually, I don't know if Erlang is strict on indentation, but we'll figure that out soon. Make sure everything's exported. Start link is exported, configure is exported, clockwise is exported, reset is exported, anti-clockwise is not exported, and also anti-clockwise should not set GPI open 1, which is the direction pin, but it should actually clear it. GPI open 1, clear. Alright. I'm just double checking so that we do not fry said PMOD accidentally. But that should not probably be a problem since we have these delays in there. I've gone for a bit of an arbitrary delay. I think that's 5,000. Is it milliseconds? I don't remember. Let's check that on DOS. See what Google gets for us. Is that correct? No, that's timer, not time, but Erlang found us what we need to find. Cool, I just got a message that it is 7. Those who want to drop off are welcome to drop off. I would just like to quickly deploy this and actually see if it works, because then I think we have had a marginally successful day, which is obviously also always good. So we have timer docs and we are looking for sleep. Cool. And sleeps for a time, and time as a default, that's milliseconds. Okay, so 5,000 milliseconds is ages in transistor world. So let's make it 1,000, because I'm sure these transistors can keep up, and then we don't have to wait so long for them to actually get to what they're meant to be doing. Okay, double check, clear the driving pin, clear the direction pin, set the driving pin. That is anti-clockwise. Clockwise is clear, set. Alright. Everything's exported, all seems sort of fine, and we are hopefully likely to not have any issues. Okay, let us kill this device and get our hands on the memory card. I've got this card reader here, it works well. Transcend card reader. I think you probably can't see what I'm doing right now, so let us do this differently. Let us say cd documents Stritzinger, which is the organization, Twitch stream, and then we've got this rover bot. That is the directory we're working in. And then we want to do a rebar compile, rebar 3 actually compile. Okay, everything's fine. Very anticlimactic. No fireworks, let's deploy. I guess one probably couldn't expect fireworks if it's such a basic thing one's trying to do. Really is a sanity check before next week at the conference. And we are almost done. This should be quick. Okay, as I said, if anyone is interested in dropping off of this call, you are welcome to do so. I see there's still, it seems, 9 viewers online. Or was that in total? I don't know. Anyway, doesn't matter right now. I still need to get used to all this twitchy business. Okay, so as you can see, it says that the deployment is done. That post script that it's talking about is a script that's on the GRiSP website that helps you to automate the unmounting of your USB card, of your memory card, which I would suggest to anyone to actually do, because it does make your life significantly easier. Alright, what can you see? This is what you can see. Okay, we will in a second need to know if everything's working, so we will get sudo screen ready, and then we'll plug in the USB cable and get into our terminal, serial terminal. Hopefully next time I can get the Wi-Fi to work, because the Wi-Fi is significantly easier to work with, and it is one of the big benefits of something like the GRiSP board. So we are losing on some of the benefits here. Let's give that a second. It's complaining about something again, yeah. But regardless, let us, in the meantime, make sure we have our commands ready. Let me see. Cool. Okay. So we have this module rover bot sub, which is actually means it's our supervisor, and probably not the most ideal place in which one should have all these random functions lying around. But regardless of that, let's continue. Okay, let's try to speed this up a bit. Okay. There we go. Cool. The terminal is done loading. This is an Erlang shell we're in. Let's paste our code. Roverbot supervisor. In other languages, this would normally not be a semicolon, but a .m1 configure. Cool. So, in theory, everything is now configured. Let us see what clockwise does for us. I'm gonna once again, as before, quickly get all the commands ready in case the motor tries to run off the table. It's not ideal because it's going to take the GRiSP board with it. Alright, what do we have? We have clockwise that we could call. We've got the very gripping and potentially destructive anti-clockwise, and then we've got a reset. Okay. So what I'm going to do now is give you a view on the terminal. And once again, I would unfortunately have to tell you what happens. Next time I will have 2 webcams and you will be able to see what happens. Much more fun. And why not clockwise? Oh, here we go. Aha, something's happening. What's happening is that we're going anti-clockwise. So let's reset. Check the anti-clockwise one. Good, stopped. Function works. So now we probably expect the anti-clockwise one to go clockwise. Sorry for that. That just means we need to, as I said earlier, since I didn't remember the correct directions, let's just check the code. We would have to swap the names of these functions essentially, and then all's good. Redeploy, no problems. Anti-clockwise goes clockwise. Cool. As you guys can probably hear, it takes that motor quite a while to start up. That is due to all of our little sleep functions we put in there to be safe. Okay. Let's try to change the direction now. Off, on, other direction. All is well. We have managed to actually rotate the motor. Took us an hour and 10 minutes, and a bit of a struggle with these potentially burnt out boards, which seems to not be burnt out in the end, which is good. Yeah, that's it. Thanks for joining, thanks for watching. I hope that wasn't too boring, and that my voice isn't too annoying to you. I've had fun, I hope you guys had fun, and perhaps later in this year or soon after the conference I can show you what we managed at the conference, and then we will have a robot running around instead of a motor just spinning. And hopefully by then we can figure out the multiple PMODs per port idea. Alright, I am going to kill this now. Cheers, it's been fun.